So before we start today's lecture, does anyone have any questions about what we covered with methods or arrays so far? Okay. Well, I want to move on to the next thing. So let me think about this. We talked about array list 2 lectures ago, and we backtracked and talked a little bit about methods, and we stepped through a top-down stepwise refinement approach. Where are you all in the labs right now? Oh, excellent. So I want to spend today's lecture then introducing and motivating the concepts about objects. We won't necessarily do a PowerPoint presentation. We'll just write some code. Let's just write some code and learn how to do objects. Do a different approach. Okay, so with that said, does anyone have any questions before we start doing this? Oh, yeah, I could do that. That's smart. That screen ain't doing anything. Okay, so here we go. Excellent. Okay, let me close this door. Okay, so we're finally getting into a point where we're a little bit more sophisticated in what we can do. So let's jump over here. Let's where am I here? LS. Let's move all this stuff into, what do I have in here? Array list. This is method stuff. Let me do this. Method stuff. Okay, very descriptive. Let's take all this stuff and just throw it right in here. Take that and throw it. Okay, perfect. So now, nice, clean. Okay, let's just create something so I can make a foo.java class file, just so we can go ahead and get our text editor open too. There we go. Perfect. Okay. So what have we learned so far about what we do with classes and what we do, but what is the motivating thing we've learned about classes? I guess we're going to do this a little bit more dialogue style, right? Like, why do we have classes? What have classes given to us? What is the motivating concept for us to implement a class in Java? So far, what has been the role of the class? Not the class, but the class keyword, the Java class keyword. When do you use it? Surely everyone's used the class keyword, right? Do you remember? So when's the one time it gets used? At the beginning, right? And then we assign a set of curly braces to define a scope, right? To have an open and close for that class. So the class is like an entity of sorts. It's a container of sorts. What does it contain? Methods. Yeah, it contains methods. It can even contain fields, right? Okay, so let's take a look. Let's actually build just a class. And as of now, everything we've learned how to do are part of the class itself. It's static to the class, hence the term static when we build this out. So let's do a public class. And okay, let's call this game. We've been doing a lot of game-oriented stuff. Suppose we're building some kind of game class. Okay, so we have public class game, and we're going to open and close the scope on that with curly braces. And so now this is going to have our methods. Okay, let's say we have a public static void main method that is a string array of arguments. Okay. So we learned that a class can have methods. So let's play around with the class as we already know how. And let's see some of the deficiencies that using class-based scoping that uses the static concept, let's see where that falls short for us. So suppose we're building out this game. Suppose we want to build out a game that has a player. So let me quickly make a player class here. Let's say I also have an enemy class. Okay, so here, let's get our enemy into there. Let's get our player into there. Perfect. Let's move this down some. Okay. Oh, let me do this. Move through to be game.java. Okay. Ain't there no more. Okay, there we go. So I have a game class. It's going to have my main method. I'm going to have my player class. I'll make it public so I can access it from other classes. So one nice thing about classes, as you recall, is it allows us to contain a collection of related methods and fields. That's what we claimed. So when I start designing this game, anything that's related to an enemy should go into the enemy class. Anything that's related to a player should go in the player class. Anything that's related to the game logic should go into the game class. And the game class can call on the player class to do things. It can call on the enemy class to do things. So let's start defining some fields. And for now, I'm not going to give them an access level. So we're just going to say, let's suppose that our player has, say, for instance, a X. And here, let's do it the way we have been doing. X. Let's say that the player is also going to have a Y position. Okay, and let's say we create that start method in the player. Where we can pass in an X and Y into the parameter space. And then we will go ahead and assign to player X, that value of X. And to player Y, that value of Y. So we're taking data that's passed in local data to this method, and now we're assigning it into the class field, the static class field. And then here, let's make a toString method too. Make this static. Or I'll call it something else for now. Let's call this, I still want to make it static, but let's call it toText. Where here, toText, yeah, I will return string.format. You can now use a formatted string. Let's give the player a name too. There we go. So our player now has, so the fields that go into the class kind of represents the properties that define a player. So let's say we're making this generic game up to this point. This game just has a notion of having an XY position and having a name for our player. And so let's give our, and all this is going to come from this start method. Just like so. So here, let me go ahead and do %s. Let me put maybe that this is a player. And let me give the XY coordinates at and %d. %d. And let me do player dot name. right? That's my S, and then I'll do my player dot X, and then my player dot Y. Okay, so I have two behaviors inside my player, the ability to represent my player as text and the ability to start my player up. Let's actually give one more thing to our player. Let's say that's good for now. Okay, let's do the same thing. I'm gonna do a faux pas here. I'm going to copy all of my code and say, well, an enemy should probably have similar things. An enemy should have a name, an enemy should have an X position, an enemy should have a Y position. We're going to violate the stride principle, but we'll learn how we can make this better later. One step at a time, but for now, I'm just going to copy and paste, and instead of player, I will call this now enemy. Okay, so now this is probably what you're relatively used to so far, right? This is what you've probably been playing around with in terms of your own implementation on being able to at least separate the roles and responsibility of your code base across different classes. And so here now, inside my main method, let's actually play around with this. Let's actually create. Oh yeah, thank you so much. You see the problem with copy pasting? You have to remember everything you did and change it. Yeah, I don't want that to say player, I want to say enemy. Oh yeah, and all of this stuff here. Every instance that says player has to say enemy. Otherwise, it's not going to work. Okay, and it's going to be the same here, inside of here. Enemy. 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 Okay, perfect. So now no instances, I don't need to import this. No instances of player appear now in enemy. Okay, so we have a basic scaffold of an enemy. We have a basic scaffold of a player. Now we have right here let's make some helper methods in here. So let's do a public static void start method. And so maybe in here, what we'll do is we'll say, hey, what we're going to do is we're going to access the player class. We're going to tell the player class to start, and we got to give the player class a name. Let's say that the player's name is Ted. And let's say that we start the player at 3, 4. And then we might go player dot, not player. Let's do then enemy dot start. And let's say that this enemy's name is Goblin. And let's say that the enemy starts at 1, 2. So now here inside of my start menu, I'm going to say, okay, let's start our code up. Let's start the game. And then let's say here, let's do public static void show. And what this is just going to be a printout of where everything is at. So we'll just do 2 string methods for that. So what we'll do here is we will get the string that represents the player text. And from player, I will call the toText method. And here I will get the enemy text. And here I will call on enemy to do toText there. Perfect. Now what I'll do is I'll do system.out.print. I'll just do println, make it easy. I'll print out the player text, and then I'll do the same thing with the enemy text. Perfect. Okay. So then once I have that, let's go into here and just do show. Let's clear this out and let's take a look. at what we get when we go ahead and compile our game. Yeah. And when we run that, we see that the player Ted is at 3-4 and the enemy Goblin is at 1-2. Yeah, that's exactly what we expect. Okay, so what are some limitations of this current build? What if I want to have a second enemy, right? What if I did this? What if I wanted to dynamically add? Would this work? Could I then to get Goblin start dragging at 7-7, say for instance? So would this work for me to add more enemies if I wanted to have more than one? Sure. Well, let's see what happens. Well, let's see what happens if we run our code. Well, the issue that we're going to have is we can start Goblin. Okay, let's step through what happens here. What happens when in my start method? So let's start at the main method. Let's track everything that happens during the life cycle of our application to really understand if we've added a second monster or not. So let's start from where the application starts, always the main method. The first thing we're going to execute then is a start method. Let's jump to the start method. The first thing we're going to execute is the player.start method, and we're going to pass it Ted 3 and 4. So let's go to player and let's see what that. So this takes in Ted 3, 4. Here we're taking the class field, right? So we have all these static fields that are a property of the class itself. I'm going to set that to Ted. So the advantage to this is even after this method is done calling, that value still exists. That value will exist for the life cycle of the application when I set it. So name is now Ted, X is now 3, Y is now 4. And when I'm done that's it. I return control back over to the game method. And then I run enemy start Goblin 1, 2. But then what we do here is we jump over to enemy and we're passing in Goblin 1, 2 as the ordered set of parameters. So what we're going to do is we're going to assign to the class, the static class variable, the static class field, the name of Goblin, and then we're going to set the X value for to 1 and then the Y value to 2. And after we set those from the local variable, from the local method, from the local set of variables to the fields, the class fields, to the class scope variables, then we jump back to game and then we call enemy start again. And then what we do is we jump here. And so what is that? That's Dragon 7, 7. So name, what was the name before? Was there a name before for enemy name at this point? What is it? Goblin. So now what is it? So what we've done is we've accessed what was the name Goblin and we've overridden it. Because the value of name can only have one value at any time. So I can't have two competing values at the same class field simultaneously. It can either be Goblin or it can be Dragon, but it can only be one, right? So we've overridden, we've undone what we've done with Goblin to overwrite it with Dragon. And it's going to be the same thing with the positions. If I set X to 7, well, it's no longer 1 anymore. We've overridden the value of the X position. And if we go to Y and we overwrite the value of 2 with 7, it's the same thing. So you could think of this enemy as only being able to exist in one state at any given time. And every time you mutate the state, whatever it was before is different now. It's changed. It's lost. So with class fields, you can only have one set of values for the entire class. That's what that means. So these values last outside of the methods, but when you set them, they can only have that one value. So that makes it difficult if I want to have more than one enemy, right? Then what's my solution if I use this approach? How can I have a second enemy? I have to make another class, right? I have to make another class. Let's call it enemy 2. And then if I want a third enemy, I'd have to make an enemy 3. Let's see. Let's actually do this. Instead of talking about it, let's actually do. In fact, I'm going to do this in the most awful way possible. I'm like, I have an enemy 1 class. Okay, so actually, if I'm going to start numbering them, let me not just have an enemy. Let me have an enemy 1 and an enemy 2. And does anyone see what principle we're violating here? Yeah, exactly. We're doing a lot of repetition here, right? Okay, let me close this enemy. And suppose I wanted a game that had 3 enemies. Okay, so then what I would have to do, let's see what I have to change this time. Enemy 1 would go to enemy 1, 1, 1, 1, 1, 1, 1, save. 2, 2, 2, 2, 2, 2, 2, 3, 3, 3, 3. Anyway, you could see, let's test this out, make sure that this works the way we expected. But the idea is by having 3 different classes, each maintain their own set of fields, this would legally allow us to have our 3 enemies, right? And we'll test this out, but we could probably already guess this isn't a great solution. So enemy 1, enemy 2 is now dragon. And now let's do this. Enemy 3 is a orc. That's at, I don't know, 5, 1. So now when I go here, I will go to enemy 1 to get the goblin. Change this to goblin. Perfect. Okay. Then I got to do this again. Going to copy pasta. Dragon from enemy 2. And what is that? Orc from enemy 3. And then let's print out system.out.print. What was the last one? Oh, I have dragon. No. Yeah, perfect. And let's do a system dot out dot print ln. And what was the last one? Work. Okay. Save that. Let's compile. Let's run. Okay. We now have the behavior we initially wanted, right? We have a player. We have a goblin at 1, 2. We have a dragon at 7, 7. We have an orc at 5, 1. And then every time I want to mutate any one of these, I have to go to that specific class to change those specific fields, because using the static keyword means that that class can only have that one set of fields. So where does the static keyword break down for us with this demo? Is it evident? Is it the fact that it is actually pretty routine that when we define a class, remember, a class just models a set of related behaviors and properties, right? So a player is a set of properties that which we demo out, which we express as fields, like a name, like an X coordinate, like a Y coordinate, like a strength, like a defense, like a speed. Like these are all properties that can define what it means to be a player. And they could all be, the properties are all individual data types. It could be strings, it could be integers, it could be doubles. Okay, in addition to that, players have behaviors. A player can start, a player could potentially move, a player could potentially attack. So all those methods go in there. Same with enemy, right? An enemy is defined as a set of related behaviors or properties, and the behaviors are usually implemented as methods, and its properties are implemented as the set of fields that are defined within it. Now, probably is the case is you can have more than one enemy at once. You can have more than one thing that you've modeled inside of your application. So let's suppose that we're making like a game like, for instance, so this already breaks down on the drive principle. But say, for instance, we wanted to make a game like what are those like dodging style games like Asteroids or like in Space Invaders, or like the idea is that, or like one of those like 1942 games, right? So you have a player. Is everyone familiar with this genre of game? So it's a real, it goes back decades, right? Like this is a really classic genre. You have a player unit that has to dodge either enemies or projectiles shot from enemies. And if you get hit, then you lose the game. And if you dodge it and get to the end and get the high score, that's the equivalent of winning, right? Okay, has everyone played a game like that or seen a game like that? So we're on base with this. Okay, so let me ask you this. How many enemies do you think is inside a game like Space Invaders or Asteroids or any one of these Dodger games? Hundreds. Yeah, I mean, yeah, in fact, I can even argue it could be an unlimited number, right? Based off of how long you live. So how could we implement an approach that supports, I mean, look at how much work it took just to make 3. And that's a lot of overhead and a lot of code bloat, a lot of duplication. And it only got us 3 enemies, not hundreds, not thousands, not an unlimited number. So what we want is a new approach. We want an approach that we can define a class once that models something like an enemy, but it allows me to build any number of enemies from it without having to make a new class each time I need to create a new set of values that represents an enemy. And that's where objects, that's where instances, that's where constructors are going to come from. That's the default value that our fields have, our instance fields have when we remove the static keyword. Let's take a look at that. Let's go back, reduplicate my enemy so that it's just enemy, and we will play around with this. So let's go here, call just something enemy now, because I overwrote that, I think. And we'll refactor our code. So here, instead of enemy1, I'll call this enemy. Instead of a static string name, it will now just be string name. Instead of static int x, it'll just be int x. And instead of static int y, it'll just be int y. And here, now this is a secret though. This is not a secret. If a secret would be an awful secret. This is an important concept. Any data types that don't have the static keyword that's at class field can only be accessed by methods that also don't have the static keyword. Another way of me putting this is that only static methods can only access static fields. Is everyone on board with that? So therefore, if I try to just do this from the get-go, this should fail. This should tell me I can't do this. Well, let me get rid of, well, first of all, let's see what happens if I try to compile the code, just removing the static keyword. And then we'll talk about why that has happened. Can everyone read my command line? I'll blow it up some if necessary. Okay. Wait, let me go here. So the goal here is we have those 3 things. Let's see if I can tell enemy, but let's just try to compile. Let's just, instead of game, we'll just compile enemy just to see what error messages it's going to tell us. Oh, no error messages. Very interesting. Okay. So then let's use enemy then. Let's we'll just do it in the main method here. So let's take a data type enemy, and then what we'll do here is enemy, and let's call this E1, or we'll just call it monster. It is going to be enemy dot start, and this will be our we'll implement a computer bug at -1, -1. And then here, let's just do a system dot out dot print. And yep, we'll do that with the monster. Okay, and then here, just for now, let's comment out our start. Let's comment out our show, because we're just going to test out this concept right in our main method. Okay, so let's do Java C game.java. Okay, perfect. Now let's start looking at what some issues are here. So I'm trying to compile this, and I'm trying to compile it when I'm using it in something else. I get this error that says this is an incompatible type. It cannot be converted to enemy. Enemy.start, computer enemy. Oh, yeah, it makes sense. It doesn't return anything. Okay, let's save that. Okay, so now here we have cannot find symbol monster. Oh, well, yeah, let's do enemy.toText. And I'll just print that out. Okay, let's clear this out. Oh, let's clear our terminal and recompile and see what our new error message is. Okay, so let's see here. It says cannot find symbol enemy.toText. I guess I need to do camel case. Okay, now let's run that. So enemy computer bug at -1, Okay, let's go here. I remove these. I access those. Oh, it's interesting that Java no longer throws a error for that. What's that? I mean, there should be. Let's see here. That's a good question. Let's get rid of rm.class. But even if, okay, let's remove all of our class files. And let's compile and let's run. Oh, yeah, I mean, it's nice that it goes and runs this without declaring these as static, because it's still going ahead and creating those. Interesting. Always you get these nuanced things you don't anticipate sometimes, because I never code in this approach. So sometimes I would expect Java to be a little bit more verbose than it actually is. So it's fun to know that this is now allowable. Okay, but the idea here is that it doesn't solve any problems then if this is working, because it's still going to be a class field. Because if I do the start method again, actually, since those aren't, we can just do this. Like, since we made those public, we can just access them directly. So we could do enemy dot. Let's do 9,9. Okay. Let's see what happens here. So it allows us to update, but it doesn't save any problems because we're still just updating things in the same class. So this isn't quite there yet, but it's super interesting now to me. We no longer have to declare our fields as static. I had no idea that they've made that an optional keyword in Java that they now implicitly adhere. That's crazy. That is, I'm sure there's a reason for that. Okay, so what I want to do is not access these as if they're class variables, though. I want to access them. I want to use my class as if it's a template to build out enemies. So I'm going to build a special method. So I'm going to comment this out. So this is kind of the framework that I want to use. In fact, I'm interested now. I'm not going to get rid of that. I want to see if I can do both of these at the same time, because now I'm in an area where I want to test. So we're going to create a public method, and this is going to be the only time where this happens in Java. We're going to create a method where the return type and the name is the same thing. And it has to be the name of the class. So instead of having a method that has the return type and then a name, like every other method you've seen, we're going to build a constructor. A constructor allows us to produce a individual copy of all of the class field, all the fields, we'll call them instance fields, all of the instance fields, all those fields that are not static, we'll be able to create a copy of them and give back to the calling code. And the data type for what it gives back is of the enemy data type. So a constructor allows us to start constructing individual enemy objects that all have their own name, that all have their own X value, and all have their own Y values, so that we can set each of them individually. And they can all coexist at the same time, so that you could have an orc and a dragon and a goblin and thousands of other enemies, all built from the same class definition. That's where we want to go. That's what, when you hear object-oriented programming, OOP, that's what it's all about. It's about being able to define a class as if it were a blueprint on how it can then manufacture any unlimited number of instances that comprise the fields and then have those behaviors. Okay, so the way that we create a constructor, this is my constructor right there. It has to have the same name as your class, and that's both the return type and the name. So let's just, and here our constructor, just like any other method, is allowed to have parameters to be defined inside of it. It's allowed to have a set of arguments. So here, let's do the same thing that our start method looks like. Let's say that we have a string that we pass in for name, and let's say that we have an int that we pass in, that's our X value, another int that we pass in as our Y value. Now, this is the thing. If I want to access that, we know, oh, I see what's been happening. Do you guys see what code was working before? I had no idea. Okay, now that I'm actually looking, it's the copy pasta. The reason why we avoid just copy pasting code. Look at the variables I was actually setting. Those are static variables. Okay, now let's do this. Let's go back. I'm going to break midway through. I'm going to change all this stuff because Java is going to break the way I wanted to. I just didn't implement the code I should have. There, that's exactly what I wanted. So this is also the issue we had before, is that when we try to go ahead and on line 14, what is line 14? It's here. So in our start method, when we remove the static keyword in enemy, we can't do that. We can't access it anymore, right? Because it's not part of the class anymore. It's an instance field. It's not a class field. So what this is going to tell me is, hey, your error, this is a non-static variable name. It can't not be referenced in a static context. Well, what does it mean to be in a static context? Well, this method's declared as static. Therefore, any statement that's in between the block of the curly braces, anything that's in that method body, is in a static context. The only thing that's available to you during a static context call are static variables. Since we remove the static keyword, we can no longer access that name, that X, and that Y, because those have now become instance fields. And the only thing that can access an instance field is an instance method, or a method that does not have the static keyword, a non-static method. And the reason why is that once we remove the static keyword from it, we can now have name X and Y have duplicated copies that coexist, like I said before. So the methods that access those have to know what set of X, Y's, and names is accessing, right? There's not just one, there's any number of them. So I can't use things like enemy or just the enemy class anymore. I got to use a different keyword to access the instance fields. And so there's a special keyword in Java that allows us to grab a value for a particular instance. So let me go back to my constructor and show you what that is. So I want to set name. I can't use class name because it's an instance. So I'm going to use the this keyword. So for this instance that we're creating, we will have an X. And now that's the instance field that's referencing this, but that, remember, that can, this is where you have to mentally think about it. Each time we call the constructors, creating a new copy, like a new container that has its own X, Y, it wraps all the data inside of it. So every time we call this, it's creating new instances of this. So you can have 20 different thises, and each this communicates with its own, it refers to its own individual values for that particular instance. So this dot X will be assigned that X value. This dot Y will be assigned that Y value. This dot name will be, and again, we don't have to put these assignments in any particular order. I don't know if I've ever shown that I can just put my assignments in, like, I'm passing my parameters as name, X and Y, but I can assign X, Y name. That's fine. There's no reason why I can't do that. Okay, so now when I do that, I'm still having issues here because there's no such thing as a static name or static X or static Y. I have to remove the static context from it. And then it doesn't make sense to refer to the class to access that because there's no class variable that has a one set value for the entire class. These are instantiated. They're different every time I build a new enemy. So here, I'd also want to make this a this dot name, a this dot enemy. Oh, gotta get rid of that dot. And okay, so now I'm going to replace every instance where I'm using the class name with the this keyword. And actually, I'm going to change this instead of being, I'm going to call this toString. I like that better. So we're going to convert it to a string and return back a string. Oh yeah, I missed that. Yeah. Okay, perfect. Okay, so now what this should allow us to do.
You're formatting a string
Yeah, right here. Mm-hmm.
What is that? Just that front part.
So it should be mentioned that string.format, first of all, let me just highlight that string.format is a mechanism that's very similar to printf, which is short for print format, which means that I can start with a formatted string or string literal, and I can put special placeholder characters. It's a %s or %d or %f. And then after I've created my formatted string, for every instance where I had a placeholder, I have to supply some value that the JVM will then replace the placeholder with an actual string or integer number or floating point number, right? And so what is happening here is this is a string literal. So this is technically just a piece of text, right? But I'm trying to produce text that highlights, this is an enemy. And then this is the placeholder %s, so that would be replaced with this dot name, which would be the enemy name. So it'd be like orc or goblin or dragon. And then I would put the @ and then a set of parentheses and then a %d and %d, two more placeholders, which will then be replaced with the X and the Y values of what's happening in this class. Okay, so let me save this here. And let's jump back to our game and take a look at this. So here, so the question is, let's go back to start. So this is our old version of start. I'm going to, and our old version of show. In fact, I'm going to comment this out so we can look at it later. So we can do a comparison. But let's take a look at this. Let's do a new, so here, public static void start. So let's do the same thing we did in this method, but now that we've defined these instance fields, we've stepped back away from using, nope. I kept these older things so that we can compare and contrast later. So this is the new class, the non-static, the one that uses instance fields and instance methods. This is instance fields, or what we sometimes refer to as instance variables, is probably what you hear them as well. This is a constructor, and this is an instance method. And the reason why is none of these have the static keyword. There's not the static keyword anywhere in this class. We've removed this class from any sense of being static. Okay, so now, whereas this was our old implementation, static was peppered all throughout it. All of our fields were static, all of our methods were static, but that meant that we could only have one set of values at any given time. So let's see the advantage of removing the static keyword. So here inside of my start method, I can now have an enemy type. So what we said is what the constructor does is it builds a new instance of an enemy and it gives it back to us. So now we can store that instance inside of our software, inside of our main method or our start method or application or whatnot. So actually, let me come up here and let's say I have a, let's actually make some properties so I can share these between. So let's say I'm going to create a enemy array that's called enemies. Oh, not quite right. Let's see. Let's see. Enemy. Let's create this to be static. That way I can access it back and forth. What's going on? Enemies. Wait, enemies array is let's say it's what? It's going to be a new enemy array of let's start with 3. Okay. Another advantage is that we can start grouping or collecting things based off of the data type as well. Okay, so suppose that, oh, I guess I can just do this. Let's do enemies is equal to new enemy at size 3. Okay, so that holds us, let's just hold 3 enemies. Okay, now what we're going to do is we're going to create an enemy. Actually, let's do this. Let's create enemy goblin. What's going on? Okay, new enemy, and I'm going to pass it in goblin. What was the location I used for goblin? 3, 4. Okay, let's say that I do an enemy that is a dragon. And I'm going to call the enemy constructor, and my enemy constructor, just like my start method, takes in those parameters. So this is a dragon. What was my dragon at? 7, 7. And then let's say I have a new enemy. That was my orc that I will call new enemy. And let's say that this is the orc, and the orc was at 5, 1. Okay, and so instead of doing this, I'm just going to create an initializer list where I can pass in my goblin, I can pass in my dragon, I can pass in my orc, and just store all those into my enemy. Oh, I guess I can't do that because I've declared it here. Now, let's do this. Well, how do I want to do that? I'll do this. Enemy mobs is equal to, and then I'll set enemies equal to mobs. Okay, that'll work. Okay, let's step through a little bit about what I'm attempting to do here. So the first thing I did was I am invoking the constructor. So that constructor was that special method that we created an enemy. Now, in order to call a constructor, it has to be prefaced with the new keyword. The new keyword followed by an invocation to a class's constructor will create an instance of that class. So any instance fields that are declared in that class will be created in memory and then given back as an instance, as this complex value. This complex value has all of these nested properties that define the name and the X value and the Y value. So notice I can have an instance of enemy, if I go back to enemy, that has three different values. It's three different properties. One's a string and two are ints. So here I can set the first one by passing to the constructor the goblin, as goblin 3 and 4, and then that's going to give me back something. So I'm going to store it into memory so that I don't lose it. If I don't store it, I lose it, right? Remember, that's one of the rules we set up in one of the first days of lecture, is that if without a storage operation, whatever gets processed on a single line of code is thrown away. So we get back this instance of an enemy so we can then store it, but now it's going to be a reference data type. It's a reference data type because it's made of all sorts of different elements, all sorts of different variables. So it's a way of containing a individual monster. In this instance, we can call it goblin. Goblin's just a variable name, but the data type is enemy. And so then we can call the constructor again and now give it the dragon name, give it 7 as the X coordinate, 7 as the Y coordinate, and save that in a different variable. So now I have two different instances of enemy that coexist at the same time inside of this method. And then, but I'm able to distinguish them from one another because I can store them in individual variables of data type enemy. And then finally, I can make another variable of data type enemy to hold another instance where I'm going to call that constructor and I'm going to pass it in the same things we were passing to start. But notice now, instead of having to build 3 different classes, like what we were doing here, I can build one class and just keep calling the constructor to construct new instances. Then what I'm going to do is I'm going to take those 3 enemies. They're all enemies, which means if I wanted to, I can hold them inside of an array. Because one of the rules of the array is it's a container class that holds similar data. So as long as the data type is the same, I can have those values in there. Well, these are all data type enemy. So I can create an enemy array. And here I'm just going to use an initializer list just to make it easy on myself. And so the problem is what I want to have access to it, and I don't want to pass it around between methods. So I made a static variable inside the game class that can hold multiple enemies. But remember that in order for you to use the initializer list, you have to declare and assign at the same time, right? You can't initialize a pre-declared array. So I create this throwaway array. That's what mobs is. And then once it's created, I'm going to set that array to be assigned to the enemies array, which will now exist outside this method. Does anyone have any questions as to what I'm attempting to do inside here? Does everyone understand the concept? Any questions? Does this seem obvious? Or so I don't know if I'm getting stares because this is confusing or if it's obvious. So give me a little bit of feedback so I know what direction to go, whether I need to speed up or slow down. Okay, yeah. Is there a particular line that you're at that you want re-explained? Let's start through a step through. So because let's look at what we changed here. So the first thing I did was create a static field inside the game class called enemies that has the data type enemy. So does everyone understand that enemy now is a legal data type that we can now store as a variable type, the same as what we could do for a string or like a int or as a float or as a double, right? So notice whenever we create arrays, we always said it's the data type and then the box notation. The box notation says, oh, this is a variable that can now hold that type of data, but more than one value of it. So does this much make sense to everybody? Okay, so now what we're going to do is let's look at the start method. Let's look at the first, let's break down each statement. I'm looking at line 11 in particular. I'm going to break that assignment operation down into the right-hand side and the left-hand side. So we always resolve the right-hand side first. This right-hand side is using the new keyword. The new keyword, think back now on it. Think about, you've used it before, but now I'm going to challenge you to actually understand what you were doing when you were using it, because we never really discussed what was happening. With the new keyword, it causes the JVM to go search out a constructor and invoke it and produce an instance of that thing. When have you used a new keyword before? How many times? Scanner, like first day or second day of class, when we're talking about input and output, you have to create a new scanner. And so in lab, it was purposely designed where there are instances where you produce more than one scanner, probably one to get input and then another to parse a string. Isn't it? Didn't you have a problem like that in the lab? So what that illustrated, whether you realized it or not, was you produced two different scanner types, two different scanner instances that both looked at two different things to scan. So in the same piece of source code, there was two scanner objects, both scanning different things. One was your keyboard and the other was a string. Do you remember that? So this isn't dissimilar to what we were doing there. And the reason why you were able to do that is you had to use the new keyword twice. And when you called the scanner's constructor, you passed it what it scans over. And in one instance, it was probably system.in. And in another instance, it was probably a reference to the string you want to scan over. So when we're doing here, what we're doing though is we're flipping that. With the scanner, in the instance of using scanners, that constructor was already defined for us. So we were just learning how to call it. Now we're learning how to define our own constructor, and then we're showing you how you can call it from a different piece of source code, from some piece of client code. Okay, did you have a question? The new keyword has to preface a constructor, a call to a constructor. What's that? So one big thing about Java is they will highlight certain keywords. So new is a reserved word in Java, which means that you can never use it as a variable name. And so when Java sees the word new appear in source code, it knows it's about to make an invocation to a constructor, and it's going to return back, it's going to get back an instance. So it's a clue to it to say, hey, I have to jump somewhere else in the code to get this constructor. And then here is the actual name of the constructor method that we're invoking. And a very rigid rule in Java is that a constructor has to have the same name exactly as the class. So if the class is enemy, then the constructor has to be enemy. Let me jump back to that. Then the constructor has to be enemy. And since the return type and the name are the same thing, it's the only method in Java that appears not to have a return type. In actuality, it does. In actuality, the return type is an instance of enemy, which just so happens to be its name. So really what's happening is it's grouping the return type and the name into the one declaration. So you always have to call your constructors that. And remember, when we create our instance fields now, our non-static fields, no static keyword, and then we start using the this keyword in place of the class name. So every place where we were using enemy, we now use this. And the reason why we have to do that is because this can refer to any number of instances of this class. So to try to paint a picture of this, in the instance of Goblin, when we call this string toString, that returns this name, this X, and this Y. Well, for Goblin, those values are going to be Goblin 3, 4. For Dragon, though, it's going to be Dragon 7, 7. And for enemy, it's going to be Orc 5, 1. So those values of name X and Y can actually be they can actually have a different group of values for each instance that they appear. So the methods that operate on them have to be instance methods. They have to operate in the context of a non-static environment. It has to know, oh, when you're looking for this string, the information for this particular instance, you want dragon, or you want orc, or you want goblin, right? Because there's actually a unique set of values for every instance, and they can change over time. Like I can go and then tell the dragon to move, and then it could be at 6-7, but goblin could still stay at 3-4, and orc can still stay at 5-1. So I can independently mutate each one of those instances without having any effect on the other ones. Very powerful mechanism. Notice how this really adheres to dry. We only have to write one class to represent any number of enemies, and then programmatically, we can just invoke the constructor and get as many as we need. And now we don't have to write 3 different classes for 3 different enemies. And you see, well, how faulty that was just over the course of this, just for a tiny example of printing out, of creating state and printing it out. I had several errors where I was referring to the wrong monster because I cut and paste, right? I'm like, what's going on? And then when I actually sat down and looked at the code, it shows how even someone who has been a seasoned developer, when you rely on cut, pasting code and just trying to get things to show off because you have something else you're trying to do, you miss all that minutia, and then things don't work the way you think it should. And so much of development time could be wasted on debugging. The reason why you rigorously test is the hardest part of development is when it's not done right, and when you're having to debug things. So that's why we do adhere to these dry principles. Anyway, so we call this constructor once and save it to a instance of enemy storage operation that we'll call goblin. We'll call it again here for dragon. We'll call it again and save this third instance as orc. Then we'll take our 3 instances, we'll embed it into an initializer list and create a local array of an enemy data type that's called mobs. So now mobs has as index 0, our goblin, as index 1, our dragon, and as index 2, our orc. And then since this exists, I can just say, hey, enemies, this static enemy array, I want you now to have the same reference as this mob array. This mobs array. Now, when the start method exits out, the mobs array falls out of scope, right? It gets destroyed. It's collected by the garbage collector for Java. So remember, any local variables after a method is done executing get thrown away. They don't exist anymore. But because enemies is a class variable, it will still hold on to that reference of mobs. So we still have access to our goblin, dragon, orc there. So that's what's happening in this last line of code. So it's a scoping thing there. And I only did that so I didn't have to return anything and then build all that other complicated logic. And I guess show you a different way of doing things. So I see here, yeah, this should be very fun for the zombie apocalypse games. All of you who wanted to learn how to start implementing more than one zombie, this is the real way to actually do it. And actually, let's test this out now. So we can see the comparison between this and this. And then if I really wanted to shrink the implementation, let me shrink the implementation. I'll just do this to play some code golf. Okay, so here, an alternate approach, just to reduce a couple lines of code. Is this, right? Does everyone see how that's the same thing? Or will produce the same thing? So here, I'm creating an enemies array that will hold 3 enemies. And here inside of index 0, I'll create the first enemy that is a goblin. In index 1, I'll store the second enemy, which is a dragon, and in the third, in the second in index 2, it'll be the orc. Okay, so now let's go to show. So here we can compare these two, this versus this. And now let's do this. Public. Oh, I can't do that. I'd be inside of there. Okay, so public static void show. So let's actually display this and prove that this is going to give the same kind of output that we were getting before. So here I'm going to do for, I'll use the enhanced for loop because I'm only going to display things. So for each enemy, let's see, for each enemy, I'll call it monster as just the name. And then this is inside of my enemies array. I will do a system.out.print. And I'll pass in this monster. Let's clear this. And there we go. Exactly the same behavior we had before. Goblin, enemy goblin at 3-4, enemy dragon at 7-7, enemy orc at 5-1. But notice, because now we can group all these things, what we couldn't do with classes, you can't group classes. Classes aren't instances. Classes aren't a returned data type. They're not a reference data type in and of themselves, right? It's just a block of code that contains enemies and methods. So before, in our show method, every time we want to print something out, there's no way to do that iteratively. There's no way to build a repetition statement, to build just a for loop and say, print the thing from this class and this class and this class, right? We actually have to give the class path for each of those things. But once we can start managing our instances as if they're a variable, just like any other type of variable, then we could throw them in an array, and then we can start using for loops. We can start iterating over them. So look at the advantage here against the show. So here, this is what I had to do to show this stuff. I had to go ahead and request for the text and then display it for each individual class. But now, since I have that array, I can just use that for loop and then print it out. And I get the same output that I got here. And in fact, anytime I want to check anything, since I can group all the related instances together, I can create for loops to check to see if there's collision detections or for drawing or for all those other things. So if I wanted to create hundreds of monsters, it becomes much easier to iterate across an array of them and actually have inside the array where I perturb them, I request for them to do something, an object at a time, an instance at a time. Like, hey, effectively, enemy 1, draw, enemy 2, draw, enemy 3, draw, enemy 4, draw. But it would be more appropriately to say, hey, enemy at index 0, draw, enemy at index 1, draw, enemy at index 2, draw, or enemy at index 0, are you touching the player? Enemy at index 1, are you touching the player? Enemy at index 2, are you touching the player? So it becomes much better to be able to start organizing your code as a collection of instances derived from classes and then grouping them into arrays when you have to be able to implement something like a game or any other application where you're using a collection of entities all at once. So if something is unique and you only need one, you don't have to do that. You can just use the array and make the calls as you need them. But the moment you have more than one thing, and the fact that that thing could potentially grow out, that's where coupling instances and arrays becomes really powerful. And you'll see that in homework 6, where you actually build a Dodger game. And you're going to see when you build that game, it would be impossible to do the way that we were coding before, using the static keyword across everything. And I'm sorry, it made me cringe. I'm sorry to show you to code that way, because it's such a violation of the principles of Java. Like, we never apply the static keyword the way we do. Like, I was showing you such poor programming practices, but the reason why I do that is to highlight what we get when we remove that, to motivate what object-oriented programming is and what the advantage of introducing this concept of building instances from classes provides us. Like, that's one of the things that Java, and prior to Java C++, had really given to the software developer community. And it was a distinguishing principle against OOP, object-oriented design, versus the traditional way we were designing our code, where it was just like blocks of code and properties that you could go ahead and kind of block together. Okay, so with that said, does anyone have any questions? Does this seem kind of understandable enough?
Show and method showed on it. What is the semicolon saying?
Okay, so in the new method or the old method?
This.
Okay, so here, this, are you talking about right here?
Yeah.
So this is the enhanced for loop. It's something that we had talked about with arrays. And again, I'll go ahead and publish those videos so you can go ahead and access it. But keep in mind that with for loops and arrays are so tightly coupled together, instead of having to create an index value that is our local control variable, and then a comparison of the index variable to the length of the array, and then an increment, because remember this, I'll show you the alternate approach, like probably the way you're used to seeing your for loops look like this, right? And this would be enemies.length. And this would be, so usually this is an alternate way of doing this. So this and this are going to do the same thing, but then here I would also have to I'd have to index into the enemies array using this index value. But if I'm operating on an array, all arrays can use this enhanced formatted loop, where if between using the colon as a delimiter on the right-hand side of the colon is a reference to an array I want to iterate across. So recall that enemies is an array. Then on the right-hand side is the local variable name. So it's like a declaration of a local variable of the data type that's held inside that array. Okay. Then what this is going to do is it's going to assign inside the body of this for loop to the value of monster each instance of enemy starting at index 0 all the way to the last. So over the course of this for loop, the value of monster will be assigned every possible value that's held inside the array, that's held inside of enemies. So that makes, so it's an easy way to read all the contents of an array without having to have the verbosity of declaring a loop control variable, evaluating the loop control variable, incrementing the loop control variable, and then using the loop control variable as an indexer into the array. Does that make sense? So just to put in perspective, a equally valid way would have been to do this. I'll show you the one-to-one correspondence for int I equal to 0, I less than enemies dot length I plus plus, and then it would be system dot out dot print enemies at index I. So these two lines, so effectively this method and this method are exactly the same. One uses the traditional for loop, the other uses the enhanced for loop that allows you to easily read the values from arrays. I'm going to argue that the enhanced for loop is far more readable when we need to read values from arrays. Now remember, it's only for reading the values from arrays. You can't mutate the array using the enhanced for loop. So if for any reason you have to write into one of the cells of the array, you still have to use the traditional for loop to access that value and overwrite it. Excellent. Any other questions? Oh, that's a good question. Well, there's only one way to find that out. Let's see what happens if we try to invoke without the new keyword. Because you said every time we invoke the constructor, we have to alert the JVM that, hey, we're trying to invoke a constructor using the new keyword. I've never actually tried to do that. So one way to test in Java, it's super easy, remove it and test. Here it says cannot find symbol. So now it's looking for probably a method or a class or something, probably a method. It's probably just looking for a method called this. But constructors are a special method. They can only be called when you preface with new. So it doesn't look for it the way it looks for a traditional method. So it just won't work. So if you get this error though, what that means is you haven't used the new keyword. If you look, it's like And the moment we do that, we should be able to compile again. Perfect. Any other? No, I guess outside of topics, do you prefer just to do these walkthroughs like this, or do you prefer the PowerPoint slides? I'll let you think about that and let me know in Discord, because that'll let me know if it's worth me putting together more PowerPoint slides or just doing these code walkthroughs where we can talk about it. Excellent. If there's no other questions, we were past our time, so we can go ahead and everyone have a great week. And I will see you next. We have class next week. It's like it's November 1st, right? Yeah. So. Good.
I assumed this affected my